In the last section, you learned all about the properties of parallelograms. And so we know that opposite sides are going to be parallel, opposite sides are going to be congruent, opposite angles are going to be congruent, diagonals are going to bisect each other. So we've got a lot of different properties that you've learned for parallelograms. And again, what you learned is one direction. If it's a parallelogram, then all of this must be true. Now we're going to reverse it and go the other direction and say, if this is true, then it must be a parallelogram. So in problem number 1, you're given 3x minus 5 and 2x plus 1 for opposite sides, and x plus 2 and y for the other pair of opposite sides. So what we're going to do is figure out what are the values of x and y that would make this into a parallelogram. That means that the opposite pairs of sides have to be congruent. So we can do two things here. We can set up an equation that takes this quantity and this quantity, or that value and that value, and sets them equal to each other. So 3x minus 5 equals 2x plus 1. We can also do the same thing with these. X plus 2 equals y. So the last section we did this in order to find out what x and y are. In this section we're trying to figure out what x and y are in order to make the parallelogram, or in order to make the shape into a parallelogram. Now if you look at these two equations, you should see one major difference. In this one you're only dealing with x's. In this one you have both an x and a y. What that tells you, let's work on this one first. Because if we just have a single variable to work with, we can solve that very easily. Then what we'll do is, once we've got that x, we're going to take that and substitute it in over here to find out what the y value is. So 3x minus 5 equals 2x plus 1. First thing that we want to do is get the x's on the same side. Since this one's got the smaller coefficient, we're going to move that one over. So subtract 2x from both sides. That leaves you with x minus 5 is equal to 1. Then add 5 to both sides in order to isolate x, and you get x is equal to 6. So now let's take this 6, plug it in over here. 6 plus 2 equals y, so we know that y is equal to 8. So again, before we call this problem done, let's go ahead and plug these back into the parallelogram to see if it gives us congruent sides. And if it does, we know that we found the correct values to make this into a parallelogram. So we've got 6 plus 2 gives us 8. Y is equal to 8. So we've got these two sides we know are congruent. Now we just need to make sure that these two sides are congruent. So 3 times 6 is 18, minus 5 is 13. And then 2 times 6 is 12, plus 1 is 13. So we've got a congruent side here, a congruent side here, congruent and congruent. So then that means we found the values that make that quadrilateral into a parallelogram. At this point we have a few things that will allow us to prove that a quadrilateral is a parallelogram. So that list includes, if you have both pairs of opposite sides are congruent, then you know that you have a parallelogram. If you have both pairs of opposite angles are congruent, then you also know that you have a parallelogram. Then if your diagonals bisect, you know that you have a parallelogram. There's now a fourth thing that we're going to take a look at that will allow you to determine if you have a parallelogram or not. And that's if one pair of opposite sides, so say the top and the bottom side, are both parallel and congruent. If they're both parallel and congruent, then that means that you have to have a parallelogram. So this is what it would look like being marked up. If we go over to problem number 3a, we're being asked to determine if there's enough information to say that this is a parallelogram. So what we're going to do is take a look. We've got this top and this bottom. We know that they're congruent because both of them are 5 units long. Now what we've got to do is we've got to figure out if the top and the bottom sides are both parallel or not. So we've got 50 and 130. So 50 degrees and 130 degrees. And let's say that these two lines are parallel lines. And this is our transversal here. If these are parallel and this is a transversal, then that means that the same side interior angles would have to add to 180 degrees. If the same side interior angles add to 180, then that means that we have parallel lines. Well, you can see that we've again got 50 and 130. which add to 180. So since these two angles add to 180, that means that this line and this line have to be parallel. So we have one pair of lines that are both parallel and congruent, which means that yes, this is a parallelogram. Coming down to problem number 3b, we're given that congruent sides, this one and this one, or I'm sorry, consecutive sides are congruent, and then consecutive sides here are congruent. So we don't have a parallelogram. We don't have a parallelogram there. What we would actually have is a kite, which we'll get to in a later section. For problem number 3, we're being asked, why is it that if a truck lift can move from being basically just a straight line up into a rectangle, how is it that we know that the truck that sits on this top plane is always going to be parallel to the ground? So we're given that the length of the platform that the truck is going to sit on is 26 feet, and the height of the arms are 6 feet. Obviously, this is not drawn to scale here. So we've got the truck sitting here, and then presumably later on the truck sitting up here. How do we know that this is parallel and this is parallel to this ground? Well, what we know is that these arms have to be at a fixed position. They're going to be fixed here at the ground, and they're going to be fixed here on the lift itself. And so what this means is that those arms are going to have to move at the same angle, or they're going to have to remain at the same angle all throughout. We also know that since this is 26 feet and this is 26 feet, this is 6 feet and this is 6 feet, what we have are both pairs of opposite sides are congruent. And since both pairs of opposite sides are congruent in both cases, this being 26 feet as well, then what that tells us is that since both pairs of opposite sides are congruent, they always have to be in the shape of a parallelogram, which means that the bottom and the top sides always have to be parallel to each other.